we want to look at trying to discover where the vertical asymptotes are of a rational function. I have three examples here to help you have an idea to discover these things. To look at vertical asymptotes, we want to look at its denominator and try to discover where does it zero out in the denominator. So this first one, let's factor its denominator. Factors down to x minus 3 and x plus 3. So that tells me I have zeros at x equals 3 and x equals negative 3. And those are the points where vertical asymptotes occur. So if I were to graph that, I would use a dotted line at x equals 3 and a dotted line at x equals negative 3. And there I have discovered where that graph has vertical asymptotes. In the second graph over here, I want to again look at its denominator, x plus 3 all over x plus 3 times x minus 3. Chose this example because you see that I have a factor on top that I can go ahead and cancel with a factor on the bottom. So I'm just left with x minus 3, which tells me I have a vertical asymptote at the line x equals 3. But however, I can't dismiss this x plus 3 term right away. Even though I was able to eliminate it, there's no vertical asymptote here, but there's also domain issue. And that tells me that there's going to be a gap in my graph of this particular graph at negative 3. And where that graph flows at, we designate it by, whoops. I think the graph looks similar to that. We designate it by a hole at that particular point. So some of our graphs are going to have holes at a place where there could have been a vertical asymptote. In our third example over here, again, we look at the denominator, and we see that the denominator does not factor in any way that produces real zeros. So therefore, this last example does not have any vertical asymptotes.